guys, this is page 1 of our lesson on inverses and inequalities. Alright, so a function is one-to-one if and only if no horizontal line intersects its graph more than once. We're going to do some examples of those, that is using the horizontal line test. Our second item to note is that let f be a one-to-one function. Its inverse function, which if you'll notice has that f to the negative 1, that notates inverse. And what we do to get the inverse, if you'll recall from last year, is we switch the x and the y. So our original function would have an x here and it equals a y, and our inverse function is reversed. It has the y where the x was and the x where the y is. So that's our inverse functions. So there's a couple of ways to determine if you have inverse functions. One is an algebraic test. That's this first note. This is the algebraic test. What we would do algebraically is we would do a composite function of the function and its inverse. So we would insert the original function into the inverse and simplify. We should get x. Then we would do the same thing, the opposite. We would put our inverse function into the original function and simplify it, and we also should just get x. So that is the algebraic test to determine if two functions are inverses of each other. We also have a graphing test to determine if functions are inverses of each other, and if we graphed them, they will reflect over the line y equals x. So an example of that, here's our line y equals x. If we look at a function like this, we'll notice that if we fold it, think about this as a piece of paper, if you fold it along the line y equals x, you'll see that the two pieces will match each other. So these would be inverses of each other. Alright, great. We have a few examples to work that is going to help us determine whether a function is one-to-one. I like to graph them. That's really clear, a real clear indication, and we can use the horizontal line test. So let's graph the first one. It's the parent parabola, or excuse me, it's the parent cubic function. And if we take a look at it, and I basically do the horizontal line test, we can see that it will not cross the function more than once. Alright, so let's do the parent parabola. So this one is a yes. Parent parabola, it does cross it more than once. So this is not a one-to-one function. Then we have the line 3x plus 4, probably looks something like that. And again, it does pass the horizontal line test, and this would be a yes. Alright. On the next example, we want to use the inverse function property to show that f and g are inverses of each other. This is that algebraic test I was talking to you about. We want to use the algebraic test to see if f and g are inverses of each other. So let's do that. So let's do f of g of x. So we're going to take f of x, we're going to open that up, and we're going to insert g of x inside, simplify, and it does simplify to x. Then we're going to do the opposite. We are going to do g of f of x. We're going to open up the function g, and we're going to insert x inside and simplify, and we also get x. This is the algebraic test that shows that they are inverses of each other. Alright, come to a few examples. Okay, on number 3, we have if a function f of x has an inverse, we're given some points on it, so f of 2 equals negative 6 and f of 4 equals 1. Find the inverse f negative 1 of negative 6, so the inverse. So let's look at what's going on here. In the original function, that in the parentheses is my x, and that is my y. So that is my x, and that is my y. In the inverse, basically this is the x value of the inverse, but if we go back and look at the original function, it's going to be the y value. And so if you look, we're actually talking about this one right here. And you can see that when the y was -6 on this one, the x was 2. So we use that information and we say f inverse of -6 equals 2. Alright. Then the last couple on this page are finding the inverse. So let's do that technique. Let's switch the x and the y. And let's solve for y. We're going to move the 2 over and then solve for y. We'll divide by 3. And now let's use our notation. This was f of x, so our inverse would be f -1 of x equals 1/3 x plus 2/3. Great. Alright, our next one, number 5, we're going to do the same technique. We're going to switch the x and the y. So x equals y to the 5th minus 3 over 2. So we multiply both sides by 2. I'm going to add the 3 over. And then we are going to raise each side to the 1/5 power. So we get, and again let's use our notation, instead of y I'm going to use f -1 is going to equal 2x plus 3 to the 1/5. Now if they want it in radical notation, we could do that as well. But what we like to do is, if we are given the equation in exponential notation, we should give it back in exponential notation. But we also need to be sure we understand how to write it in radical notation. Alright, great. And those are the problems from the first page of notes. So let's go to the second page of notes.